PYQ 2018-17 papers. We are going to discuss haloalkanes and haloarenes chapter. 2018 mains question. Here, the major product of the following reaction is, see here, NaOH, sodium methoxide is there. This is the ionic Na plus O methyl minus. So whenever charged reagent is there, it may be undergoes SN2 or E2, right? Next, polar solvent is there. So polar solvent is favor to E2, right? Here E2 reaction means here there is no intermediate, only transition state here, but here there is no hydrogen, only hydrogen is here, that is the transposition hydrogen. Okay, this Br and H, it will be released, here double bond will be formed, so your answer will be B. Okay, next, the increasing order of reactivity of the following halides for SN1. SN1, for SN1 generally tertiary alkyl halides or X. Tertiary alkyl halides undergoing SN1, then secondary, then primary. Right? Here, after releasing Cl, the carbocation is forming. Which carbocations? In case of first, secondary carbocation. Here, primary carbocation. The third one is primary, but here benzene ring is there. The benzyl is equal to tertiary carbocation. Okay, so benzyl means, why benzyl is more stable? Because resonance. Okay, it is almost equal to tertiary. This is almost equal to tertiary. So the highest is third. So third one is highest, then first and second may, obviously first secondary, sorry, third compound I am writing here. So this is the first compound, least second, 213. 213. B is your answer. Okay, because it is the benzyl primary, but is nothing but the tertiary. Here secondary is the primary. Next, which of the following upon treatment with the tertiary sodium butoxide? So this is the reagent. Okay, so it is a strong base. It will take hydrogen. It will take hydrogen from less steric hindrance side. From less steric hindrance side. Okay. So here, okay, done. That is the functioning of this. But here, addition of bromine water fails to decolorize the color of bromine. That means there is no double bond. This meaning is no alkene. No alkene formation. See here, alkene will be forming here this bromine and here hydrogen. If this bromine is going here, double bond. If bromine is going here, double bond. So in all these P, B, C, D case, में alkene is forming. this alkene undergoing reaction with bromine, that is addition reaction, so decolorizes. But here in case of A, there is no alkene formation. Here bromine is there, but this bromine adjacent carbon pay hydrogen, there is no choice. So here it is not undergoing alkene, so your answer is A. Okay, remaining B, C, D may alkene is forming, that alkene and decolorizes the bromine. Next, 3-methyl pentoene. 1, 2, 3, 4, 5. 3-methyl pentoene on reaction with HBr in the presence of peroxide. That means anti-Markovnikov of rule. The number of possible stereoisomers for the product. See, first of all, anti-Mark H2O2 is there. So the product is, in generally Markovnikov means bromine is here, but here bromine is here. This is the, it is anti-Markovnikov product, right? Now this one also chiral carbon, this one also chiral carbon, this one, these two are chiral carbons. If two chiral carbons are there, it is there is terminal ends are different. So the formula is stereoisomers, number of stereoisomers. The formula is 2 to the power of n. Here stereo is chiral centers are 2, therefore 4 is your answer. Okay, 4 is your answer, right? Next, the major product obtained in the following reaction is, see, tertiary butoxide. Again, what is this functioning? From adjacent carbon, hydrogen is removed. So tertiary butoxide is a strong base, right? So here bromine is there, here this is the phenyl. So with the phenyl there is no hydrogen, here only the position is here. Here two hydrogens are there with one dotted, one is thick line. So this dotted hydrogen and bromine, this bromine and this hydrogen is releasing. So a benzene ring, here also benzene ring is there. This bromine, here bromine and see here dotted line as it is there hydrogen. Here one thick line hydrogen is there. Okay, remaining this double bond is forming here. So alkene is forming. Finally, B is answer. If stereochemistry is asking, then hydrogens are opposite sides, so trans. But here there is no cis trans. Just only asking the product double bond. See here remaining options. Tertiary butoxide is there. So Kabibi tertiary butoxide should not substitute in any cases. Okay, tertiary butoxide. There is no substitution. Always it is a strong base. It will be influencing the elimination reactions. Only elimination reactions, right? Next, the synthesis of alkyl fluoride is best accomplished by alkyl alkyl fluoride and alkyl iodide. Alkyl iodide is Finkelstein This is the Swartz. The direct question named reactions. So here alkyl fluoride, Swartz. D is the option. Next, one more question is here. SN2 reactions, the correct order of reactivity for the following compounds. The last question we discussed, that is SN1. Here SN2. Now SN2 order is primary is higher than secondary than tertiary. Okay, just you take it, primary say be better methyl chloride. Okay, so here methyl chloride is there, means A and B is the option. Then tertiary is the least, of course. अभी तो decide करना है second option. Here I will write the structure. Two methyls, one CH is there on the CH, two methyl groups are there, and one chlorine is there. Okay. Next one is methyl CH2Cl is there. This one. See here, after removal of this chlorine, what it is? The secondary carbocation. So it is forming secondary. Next primary. Then next tertiary. So what is the order actually? Primary, secondary, tertiary. Secondary के बाद primary दिया है. मतलब A is the wrong. Right? So only B is the correct option. You can see primary, secondary, tertiary. Primary highest, then secondary, then tertiary. Next. The following reaction, the major product, equivalent HBr. Here conjugation is there in the double bond. In that case, two types of reaction takes place in general. At low temperature, at higher temperature. So at low temperature, suppose HBr, what is this? HBr only. Suppose HBr is there. HBr में electrophilic substitution reaction first of all. So electrophile Br will attack according to Markovnikov rule, where the middle carbon. So here first H will attack, then carbocation is forming, then double bond. Okay. Now this is one carbocation, and the next option is there. Suppose if it is rearranged, then carbocation is here. So this hydrogen already is there, right? Here double bond. Now, which structure is more stable? Which carbocation is more stable? Here only CH2 plus. It is the primary. It is the allyl. Sorry, primary of course allyl. But here allyl plus one more here methyl group is there. Which is the more stable? This is the stable. Okay, stable will form at low temperature. At low temperature. Stable carbocation is forming at low temperature. Higher temperature में unstable carbocation is forming at higher temperature. So at higher temperature, the conclusion is bromine will come here. That means 1,4 addition takes place at higher temperature. At lower temperature, 1,2 addition takes place. It is very important. So here temperature is not given. So not given means we have to think about 25 degrees Celsius. Low temperature means here less than room temperature. Okay, it's not given means that is room temperature. So room temperature also considered as higher temperature. So it will be 1,4 addition here. 1,4 addition. 1 comma 4 addition, because room temperature also considered here higher temperature, because low temperature means this 1 comma 2 addition takes place approximately 0 degrees Celsius. Okay, so the answer is here D, 1 comma 4th addition takes place. Next, okay, 2015 questions completed. These advanced questions, the next video we can discuss.